Today we are going to see about the torque speed characteristics and Phasor diagram of Blpm motor. The torque speed characteristics of Blpm sine wave motor is shown in figure. For the given maximum permissible voltage and maximum permissible current, the maximum torque remains constant from low frequency to corner frequency. Any further increase in frequency decreases the maximum torque at F equal to Ia by Mb. The torque developed is zero. The shaded pole represents a permissible region of operation in torque speed characteristics. The effect of overspeed. In the torque speed characteristics, if the speed is increased beyond the point D, there is a risk of overcurrent because the back EMF continues to increase while the terminal voltage remains constant. The current is then almost pure reactive current flowing from the motor back to the supply. There is a small Q-axis current, a small torque because of losses in the motor in the converter. The power flow is thus the reverse. This mode of operation is possible only if the motor overruns the converter or driven by external low prime. In such a case, the reactive current is limited only the synchronous reactance. As the speed is increased further, it approaches the short circuit current, which is many times larger than the normal current of motor winding of the converter. This current makes sufficient to demagnetize the magnetic, particularly if the temperature is high. Current is rectified by the freewheeling diode in the converter, and there is additional risk due to the over voltage on the DC side of converter, especially if the filter capacitor and the AC line rectifier are used to supply the DC. Then the phasor diagram. Next, the phasor diagram of BLPM sine wave motor. Consider the motor. The stator carries a balanced three-phase winding. This winding is connected to the DC supply to the electronic commutator, whose the switching action is influenced by the signal obtained from the rotor position. Under the steady-state operating condition, the voltage available at the input terminal of armature winding is assumed to be sinusoidal, varying the three-phase balanced voltage. The electro, electronic commutator acts as ideal and inverter, whose the frequency is influenced by the rotor speed. Under this condition, the revolving magnetic field is set up in the air gap, which is sinusoidally distributed in states. It is assumed that the motor acts as a balanced three-phase system. Therefore, it is sufficient to draw the phasor diagram one on phase. The armature circuit is influenced by the following EMF. V is the supply voltage for phase across each phase winding of armature. EMF induced in the armature winding. EA is the EMF induced in the armature phase winding due to the flux. Therefore, IEA is equal to IAXAI. Therefore, EA equal to minus J into XAIA. Therefore, EMF equal to 4.44 F5 K into T phase. Thank you.